Right, and good afternoon and welcome. This is our seventh lead-in lesson for our 2021 school-wide STEAM Challenge. In this one, we're going to talk about just imagination, some creativity, and some just more habits that go into the entire STEAM process. So if we look at those 5 words and put them as like people, so scientists, a technologist, an engineer, an artist, a mathematician, all of them and you have to use some sort of creative skill set, some creative tools to solve a problem. So let me give you an example. So in 1962, President Kennedy basically told the United States, hey, look, we're going to win the space race. He said, we choose to go to the moon in this decade and do the other things, not because they are easy, but because they are hard. So President Kennedy right there said, you know what, here's the problem, and we're going to fix it. Why? Because, hello, the Soviet Union, they already launched a guy up into space first, and the US was like, nah, we got to win this. So that was in 1962. By the end of the decade, in July 1969, this landed on the moon. This is my Lego model of the lunar lander. There was a problem to solve. How do we get this, holding the little astronauts, onto the moon, and how do we get them back? It was a huge problem to solve. It was, all over the country, engineers and scientists, artists and mathematicians were all working to solve this. But what they had to do is first figure out what's the problem, what's the thing that we're actually trying to solve. So let's look right now at how do we actually define the problem we're trying to look at.
Problems. We've all got them. You, me, T-Swift, Tony Stark. Some problems, like forgetting to do your homework, might seem like a pretty big deal to you. But when you compare them to other bigger problems, they're really not so bad. Like what kind of bigger problems? Well, the kinds of problems engineers face, like how to safely fly hundreds of people through the air in a small vehicle from one country to another. Or how to make an eco-friendly building in a seaside town that can withstand hurricane-force winds. Or how to send a bunch of earthbound humans hurtling off into space and, get them back. That homework doesn't seem like such a big problem anymore, does it? Okay, to be clear, I'm not saying that you don't have to do your homework. If you didn't, it would definitely be a problem. Just not as big as, having to invent a spaceship. And that's the kind of stuff that engineers do. Engineers are people who want to know how and why things work. Not only that, they actually design and build things like machines, systems, or structures to help solve specific problems. All engineers, whatever type they are, follow the same series of steps when trying to solve a problem. You'll remember these steps as the engineering process. And the first step in that process is defining the problem. When an engineer identifies a problem he or she hopes to solve. But that first step isn't as simple as you think it is. So it's time for our big question. How does an engineer define a problem? Let's come up with a fake problem to solve and we'll see what we wind up with. Pretend you're on one side of a very big canyon and you need to get to the other side. So that's the problem you need to solve, right? How to cross this very big canyon. Sort of, but not exactly. We can do better. If I was an engineer and found myself on one side of that huge canyon, here's how I'd go about identifying the problem. I'd ask questions, a lot of questions, all the questions. I need to cross this very big canyon. But is that my actual problem? This canyon is very big and I need to get to the other side. I know, I'll cross a bridge. Wait, is there a bridge? Yeah, there's no bridge. Okay, can I climb down one side of the canyon and then up the other side? Definitely not. Way too deep. Plus there's a roaring river at the bottom I'd have to figure out how to cross. So I can't cross the canyon by bridge, I can't climb down and up, and I can't swim across it. What's something I can do that doesn't require a bridge, climbing, or swimming? I know, I need to find a way to fly across the canyon. And that's my problem. More importantly, that's my solvable problem. How do I fly across this very big canyon? It took a little bit of thinking and a whole lot of questions, but how can you fly across the canyon is an easier problem to address than the much less specific, I'm on one side of a big canyon and I want to get to the other side, and I don't know how to get across it. Which, strictly speaking, isn't a question. It's just complaining about a problem really loudly. So defining the problem in a solvable way is really key to being a good engineer. While that first step might seem pretty easy, make sure you treat it like the super important step that it is, because it sets the stage for all of the steps of the engineering process that follow. If you don't define a potentially solvable problem from the start, you might never, well, solve it. So an engineer asks a lot of questions to define a problem as specifically as they can, and most importantly, as something that can be solved. So how is engineer Sabrina going to find a way to fly across that gorge? You're gonna have to solve that problem by watching our next lesson.
All right, so you saw how to solve the problem, but it's not really solving it as much as it is defining it at first. You have to kind of know, what are you actually trying to do, and what is the root issue or the root problem that you're trying to solve. You know, for a lunar lander, they were just trying to get someone to the moon and back. But that one problem had a heck of a lot of other problems that came up as a result of it. So now let's look at how you actually find the solution to the actual problem, which is not as easy as you think.
Problems. Problems, problems, problems. We've been learning a lot about engineering lately, and engineering always starts with a problem that needs to be solved. But I'm tired of talking about problems, so let's talk about solutions instead. We've already learned about how engineers define problems. Now it's time to discover how they define success. I don't mean how they define success like in general, like success is graduating from a good school, or success is getting a good bonus check at work, or success is winning a lifetime supply of macaroni and cheese. Although, I'm not gonna lie, that sounds like success to me. When engineers define success, they do it in relation to the problem they're trying to solve. So, for example, what does a successful solution to my problem look like? The big question we're asking today is, what makes a solution successful? Okay, let's back up a bit. A solution is what again? A solution is something that an engineer designs or builds to solve a problem he or she has. Some solutions that engineers have come up with include the telephone, a solution to the problem of how people in different places can communicate with each other. Or the refrigerator, a solution to not being able to keep food fresh for long periods of time. Or light bulbs, a solution to not being able to see at night using something that's safer, brighter, and more reliable than an open flame. Every day, engineers design and build solutions, but how do they decide which of the many potential solutions that they brainstorm will be the most successful? I think an example would be helpful here. And we've already invented a fake problem, so why not invent a fake solution too? Back to the canyon. You know that insanely deep one with no bridge and the raging river at the bottom of it? Yeah, that one. The problem we defined at that spot was, how do we fly across this canyon? I'll be your stand-in engineer again. Being a good engineer, I know it's time to identify the criteria for my solution. Basically, I need to figure out what things my solution needs to do in order to be considered successful. Think of it like making a checklist. Number one, it should get me to the other side. And let me be more specific, it should get me to the other side alive. Number two, the thing that gets me to the other side, should be something I currently have or can easily access. Number three, it would be nice if I could reuse whatever it is once I'm on the other side. Now, if Superman's Fortress of Solitude was nearby, I'd snag him and make him fly me over this canyon, no prob. But sadly, I don't have access to Superman's secret lair. So, like any other engineer, I have to make do with what I have. So, what do I have? I've got the tent that I camped with, and that's about it. You guys, I can make a hang glider out of my tent. It's a resource I already have, and if I build it properly, it will get me to the other side alive, which is ultimately where I want to be. Plus, bonus, I can dismantle the glider on the other side and use the pieces for their original purpose, keeping me sheltered from lions and tigers and bears. Oh my! So, Superman's a solution in that if he were real, and if I could somehow contact him to get him to carry me over this canyon, he could get me to the other side alive. But he's not the most successful solution, because he doesn't meet all of my criteria. He's not currently with me, and I can't easily find him. I mean, the whole point of a secret lair is that it's secret. So a hang glider meets all of my criteria, which means that's our solution. We'll fly across this very big canyon with a hang glider. And of all the solutions that an engineer can brainstorm to whatever problem he or she has, the most successful one, the one that meets all of or most of the criteria, is the one that engineers actually attempt to design. Now, actually making a hang glider out of a tent is a different step in the engineering process, so it's one that we kind of fortunately don't have to mess with today, because I have zero idea about how to build or fly a hang glider. And anyway, remember that this is a totally fake, made-up solution. Don't go jumping into a canyon or anything with a tent, okay? We're here to solve problems, not create new ones.
So when we look at a solution, just because it's a solution doesn't mean it's the solution. When you build your streakyhedrons, just because you think it might actually work doesn't mean it actually will. You've got to kind of explore it and play around with it. So when you're done, and you've built all your forms, kind of lay them all out. It's like when you get a new Lego set and you have the bag of all the pieces, and the manual is like, how does all this bag of pieces result in this? So start there. And then you're basically building a sculpture. Sculpture, we think it's like, a sculpture of a person, some famous person. Well, that's not the only type of a sculpture. Your streakyhedrons are going to be sculptures of their own. So now you've got them all laid out. Start laying them out, putting them on top of one another, balancing them, and see if it works. See if the design kind of speaks to you, if it solves your problem of designing the streakyhedron. You don't have to immediately start gluing everything together. You can start arranging them differently, maybe put a little shtickle of tape on there to hold it together, take some photos of it from different angles, because just because it's the first time you lay out all your forms doesn't mean it's the best one. So tomorrow, on the lightning day, we're going to start building your streakyhedron. You'll hear more about the timeline tomorrow. And remember, you've got the whole kit. Even if you don't have the kit, there's still ways that you can participate in this. But you are only building one streakyhedron. You only build one sculpture. However, your teachers are going to ask you to do different things with that sculpture over the next several weeks. But again, you're only building one of them. And I will see you next period.